let's start a new lecture. We already introduced.
Wait, I'll do it.
We introduced Matlab last
It was a bunny.
I will talk a little at the beginning and then we'll actually work with some examples. So this is basically a lecture on mathematics, just how Matlab works in the environment. And you can refer to chapter 2 in your textbook, Apply Numerical Methods with Matlab. So there's actually a chapter called Matlab Fundamentals. So basically,
of course, it's a bunny.
certain built-in functions. That's the whole deal with the environment. There is a lot of functions.
If I see some tracks right now, I know them I'd never fail. A guinea pig, a longhorn cow, a crowley bug, a nightingale. Insects go in and out, up and down the forest road. Who is running all about? Billy Barrel's Grizzly Goat. No, just wait now. I think I can. Who walked here for a while? Oh, it was a furry elephant or a feathered crocodile?
How to build an algorithm.
No, I won't lose.
So just
Yes,
a quick
I will win. I know who's been here too.
introduction
It's
to
the
the
tropic jungle penguin.
topic.
And the Arctic cockatoo. If I see some tracks right now, I know them I'd never fail. A longhorn pig, a guinea cow, and of course the nightingale.
Type in are very often. So if I want to create a variable and I'm going to start working parallel with this in Matlab. Okay. So I'm actually now going to create a diary that is just lecture 2,
Oh, Bear. you know
Matlab
nothing at all, you know.
fundamentals.
Oh, yeah.
Diary, and I'm gonna give it a date because we will probably have one next week, the next time around. So this is the file I will post for you, and you will see that this lecture 2 MATLAB fundamentals is showing up here as a file. So this is files in current folder. So we can first create variables, and the way I'm doing it, and please work with me if you have MATLAB open. If you need a computer, we can have one over here, or you can actually a number of you can share the same computer if you need to. So if I want to store number 5 into a variable, I'm just going to say a is equal to 5. And I can see that variable a show up in my workspace. So now I can work with a, right? I can actually do a plus 5, and the result is 10. I could have, of course, just typed in 5 plus 5, and result is still 10. So you can treat MATLAB as you would a calculator, but it is much more than that because you can actually create long scripts that will execute in order and save you some typing. So I can also create another variable. Let's do b. It says 2 to the 3. I would do this, 2 to the 3. So that's 8, right? Plus 6, it's going to be 14. Now I have b in my memory as well. b is 14, a is 5. And now I can actually create a new variable. I can either just do a plus b, in which case my a plus b is in memory only temporarily, and it's temporarily stored in catch-all variable called answer, ANS. Okay? But if I want to store it for later and refer to it, then I have to type in c plus b. C, so this way I created a new variable that will store a plus b. Okay? So this is how I define variables. Certain things are built in. You have already been introduced to ANS, which is a catch-all answer that kind of changes dynamically as I type things in. Okay? There are certain other, so if I type in pi, this is actually pi, so I don't have to type in all of the decimals, and those are hard to type in. At some point, we also need to stop because I have only, we know that pi can have infinitely many decimals, but we can only store so many in a computer. But to the precision of the computer, we have pi in there, so I can actually do pi times 3 if I wanted to. I can work with it. It's permanently defined. There are certain other numbers that are basically, or they're not necessarily numbers. If I try to divide a with 0, okay, I will get infinity, INF, and I can't really operate with that. I can also do 0 by 0 that is not a number, not defined. So those things are predetermined, that they just tell you that basically you didn't do things correctly. Okay. But there's a difference in divided by 0 or 0 by 0. One of them is infinity mathematically, one of them is not a number, and Matlab distinguishes between them. Okay. Now, one of the main things that we will operate with in Matlab are matrices and arrays. Okay? And basically, arrays store vectors, mathematical vectors, and matrices store basically either data, just tables of data, or linear operators. So I had that example last time where I was exemplifying rotation that can be, rotation can be shown as a matrix that operates on other vectors and produces a vector as a result. So those are called linear operators. Now I can enter matrices manually, and we did that already earlier today, but I can actually do it again. So my A, actually I typed it in, so I still have it in memory, but basically just as a recap, I'm gonna change A now, and I'm gonna change it to 0157 and 369. Oh. So this is going to be my 2 by 3 matrix. So basically the moment I'm done with the row, I type in a semicolon, and then I switch to the next row. So this is my matrix A. Now let's make some of mistakes. So what happens if I don't have the same number of elements in the next row? Is that a correctly defined matrix? No. So you will get a cryptic message saying dimensions of matrices being concatenated are not consistent. Translated, your second row doesn't have enough numbers. Okay? So the messages are kind of generic, so they're kind of encompassing. They're applicable to any type of different matrices, and that's why they're so cryptic. But this is basically, you don't have a matching dimension. And this operator basically concatenates different. So basically, I couldn't execute that. I could also use certain built-in functions. So for instance, there's already a built-in function that will create identity matrix. I can of course type it in. Okay. So my identity matrix is, for instance, 3 by 3 is 1, 0, 0, 0, 1, 0, and 0, 0, 1. So this is a 3 by 3 identity matrix. As I mentioned before, if you're annoyed with Matlab basically behaving as a parrot and just repeating what you typed in, then you can suppress this output by semicolon at the end. Either way, your I is correctly stored in memory, and you can actually see it here. Okay? When matrix is stored small, you can actually see it here entirely. Or you can just say I of 3. I of 3 tells me that it's a 3 by 3. I could, of course, do I of 6 and get a larger one. So you can see how it's actually really useful to have this built in as a function. So we can just execute. I could actually do 100. It's just that I have trouble displaying all of that. Okay? But basically, it just created a 100 by 100 matrix that has ones on diagonal. This is something that, of course, I don't want to be typing in. Okay, 100 by 100 is 10,000 numbers. I'd be here typing in till late afternoon, right? So in that case, it's good to have built-in functions. So these are some examples. We will also work on later. Basically, I could, what I pointed out, somebody actually programmed this, and we will learn how to do that. So you can actually shorten your typing work by telling Matlab, okay, repeat this 100 times. Okay? So those are going to be loops that are going to repeat things for as many number of times we'd like. And then we could also import matrix data. So actually, Matlab can import things from Excel. It can read things from files, text files stored on the computer, or any other types of files stored on the computer. We will actually work on all of these types of inputs of data. Okay. And there's a joke here. Has anybody seen the airplane movie? Yeah. So then this is probably funny, but to those of you who haven't, you could just actually YouTube this segment and you will get the movie. All right. So let's do some manual entry of vectors. So how about you all repeat what's here and type it in as a little exercise without me typing in it. So there's two different vectors. This is an example of a row vector, and this is an example of a column vector. And then an example matrix. And if you're done doing that, you can also recall how to work size. So if my U is, I can check size of U by typing size of U. And it gives you that it's a row vector 1 by 3. And if my V, well, I'm gonna make my life easy and make it a 2. If you do size of V, then you will also see that it's a column vector because it has only one column. I can do size of that matrix I typed in previously. And that was, for me, it was 2 by 3, the one that I initially typed in. I can do size of a scalar as well. What is the size of one number in terms of a matrix? 1, 1, 1 by 1. Yes?
Are you on purpose making the matrices uppercase? Or is that just like
Yes. Yes. So I'm on purpose. You can name them what you want to name them, but in this course, actually, I pointed it out during the review. So my matrices will be uppercase just to make them distinguished from vectors. Now, ideally, scalars in writing, I would like to use alpha, beta, gamma, delta. I'm not going to do that in Matlab, but I will do that possibly like just in writing. Okay. Again, there's nothing preventing you from calling them anything. Now, what can the names be? There are some rules. Okay. So I can't say 3 as a 3 is obviously a number, and the Matlab will be confused, so I cannot name my variable 3 or even 3a. Okay, I'm required to start by a letter. Okay. Also, there are certain things that can be interpreted as an operator, like plus, minus, and so forth. It's not going to allow you to name a variable using those special characters. Okay. So I can also do expressions and transpose of a matrix. So whatever you typed in as a matrix A, you can assign B to be A transpose. And transpose is not T in Matlab because T could be interpreted as part of the name of the variable. Okay, so that would be confusing. But there's an apostrophe that is going to transpose the matrix for you. So basically, B is equal to A transpose. In this case, I typed in 2 by 3 previously, so the result is 3 by 3. So try to actually name a variable A minus H and see if that works. So try to see what happens. Make that mistake. Try to see what happens. That's precisely what I said. So minus, plus, question mark, things like those will not work as variable names. And we know also that operate multiplication of two scalars is commutative, so I can do them in any order. But for matrices, that's not necessarily the case. So create yourself an example. Give yourself two matrices, A and B. Let them both be 3 by 3. And check whether A times B is B times A. So the way you multiply matrices is also by using times. So I created myself two matrices. So I'm actually writing notes for that diary file. So we'll have that as a comment. This is the way to do comments, so Matlab will just ignore anything written after %sign, so I can write in comments without them complaining, oh my god, there's no command named multiplication. Okay? Because if I typed in multiplication, it would tell me that that's an undefined function. So if you want to mute any comments and let Matlab do nothing, then you put a little %sign. Fine. Okay, where was I? A times B. This is my A times B and B times A. Those are two different matrices. I can actually do A times B minus B times A. Okay, so this is a matrix, this is a matrix, they're of the same size. And obviously the result is not a 0, so therefore they're not the same. They're actually quite far away. Okay. And with vectors, it's even more obvious, right? If I have a 3 by 1 vector, let's define ourselves one. X is, well, I'm gonna go simple. Then A times X is possible, but X times A, oops, wrong A, is not. matrix, inner matrix dimensions must agree. So what do I need to do to actually make it possible to multiply 1 by 3, 3 by 1 and 3 by 3? Transpose. So I'll transpose X. X transpose is this, right? So X transpose times A. This all works, you can just type in, but just like in math, it's typically a good idea to put brackets so you don't get confused, okay? So this means that transpose will be executed first and then multiplication. Okay? All right. Okay. So I already mentioned I function, so try it yourself, I of 4 or whatever it is, whatever size that you'd like identity matrix to be. So that's going to create I matrix. And we will, as we go, look at some others. One very helpful one is just creating a matrix of zeros. So there's zeros or even ones, okay? So if I say ones of 3, I'm going to get a 3 by 3 matrix full of ones. Of course, I can multiply that by a scalar and get, well, 3 by 3 matrix full of 5s if I'd like to. And also zeros. Zeros will give me matrix full of zeros. So that's often useful for initializing my matrix before I kind of fill in with numbers. And another one function like that, there's rand. And just to be sure, zeros can work on any size. 3 basically immediately assumes that it's a 3 by 3, but technically 3, 4 would give you a 3 by 4 matrix. Okay? So for all of these, you can do that. And another function when you don't want just like simple numbers, zeros or ones, but you actually want to randomize your input, that's actually commonly done in engineering. Is any of you taking geostatistics? Or planning to take geostatistics? It's probably coming after this. This course is a prerequisite for geostatistics. So often you want to test something on some non-nice. Zeros is a very nice input. Okay, so you might not see all of the mistakes that you might be making. So if you just want a randomized input, you're going to use rand function. So rand of 3, 4 will give you a 3 by 4 matrix of randomly picked numbers between 0 and 1. Okay. So how am I going to scale this? Let's say that I actually really needed numbers between 0 and 5. 5 times rand 3, 4. Now if I really wanted them between -1 and 5. Shift it by -1. So it's -1 plus 5 times, or 6 times. Okay?
So 6 rand 3, 4 minus 1.
To get numbers, so have numbers in 0, 1, right? To get numbers, let's say what's my A and B, okay? So to get numbers between 5 and 14, okay, I'm going to say A plus B minus A times rand of 3, 4. So basically start with a smaller number, okay, and do a difference between the two numbers. So add to it any number with the difference. So obviously if the largest number here is 1, then the largest number in the sum will be A plus B minus A, which is B. And if the smallest number here is 0, then the smallest number here will be A. Okay. What's odd here? Matlab allowed me to do something. Scalar by matrix, fine, that's a matrix, plus scalar. I added a scalar and a matrix. So Matlab is actually programmed to absorb that for you, and it's going to add this scalar to every element of the matrix. This is not something you would do in math. Okay. So this is basically as if I actually said A times ones of 3, 4, okay, plus the matrix. So does everybody see what Matlab did here? So added a scalar, so correct or mathematically correct or in terms of dimensions would be this. So now it created a different random number, so, but I still got to correct it. So note that when adding scalar and the matrix, scalar will be added every matrix element. And that's a little more visible if I do A plus zeros of 3. Okay? So here I had all zeros and I added 5 to all of those zeros. Right? So it's a little more obvious what it's doing. Alright? So there are certain niceties about this Matlab environment that you can just do things and it's going to let you do them because it knows what to do. All right, we will continue next time.